Okay, hello and welcome to Lesson 10 of Module 4 for 8th grade math, a critical look at proportional relationships. We're going to start today on page 35 and go through some examples so that you can kind of have an idea of how to start this lesson. So on page 35, example 1 says, Paul walks 2 miles in 25 minutes. How many miles can Paul walk in 137.5 minutes? And it starts us with this table here of time versus distance, and it fills in 25 and 2. And we've done many of these tables as we've gone throughout math, and we're going to do another one here to kind of help us build a proportion, okay? So let's start here on the left side, the time. So if we start with 25, the most logical next value we should use is 50 because then that doubles our 25. So if he walks 25, or if he has 25 minutes and goes 2 miles in 50 minutes, he should then go 4 miles, okay? And then if we add another 25, we get 75 minutes. In 75 minutes, we're going to add another 2 here. He should be able to go 6 miles. Then in 100 minutes, he can go 8 miles. In 125 minutes, he can go 10 miles. And we're going to go one more just for the sake of our problem here. 150 minutes would get 12 miles in, okay? And what's happening here is we are going up by 25 each time on the left side here, and we're going up by 2 miles each time on the right side. Now the question, though, asks us about 137.5 minutes. Obviously, that's not on our table, a number that's on there, but we know it's going to fall, 137.5 falls somewhere in here, okay? Which means that we have an idea that he should be able to walk somewhere between 10 and 12 miles at that time. To figure it out exactly, we're going to set up something called a proportion. So proportions are, and let's write a little note here. Proportions are set up where you have a rate equal to another rate, or a fraction that's equal to another fraction. And then you can solve to figure out different parts of the fraction. So this is what I call the skeleton of a proportion. And we are always going to start the skeleton of the proportion with what we know. So in this case, what we know is that he walked 2 miles in 25 minutes. So we're going to say, okay, 2 miles in 25 minutes. Okay? And what we're trying to figure out here is how far did he walk in 137.5 minutes. So 137.5 is another piece of information we can use on the other side in our other rate. And since that's minutes, we have to line that up. So that's got to go at the bottom of this side. And it says how many miles, meaning we don't know that yet. So we're going to put that an X for our number of miles then. And if you recall from earlier lessons, when we have a proportion, it's one rate equal to another. And one way we can solve those is by cross-multiplying and setting up a linear equation. So what we're going to do is say, okay, then 25 times x is equal to 2 times 137.5. And now in this case, this is actually an easier linear equation than what we have been doing. So we don't have to do a lot of distribution here. 25 times x is 25x equals 2 times 137.5 is 275. Okay? And before we got this, and then we had to set up a chart and solve it. Well, this doesn't need a chart in this case because you're already to the last step. So the last step, remember, in solving our linear equation was to divide by whatever was next to x. So we're going to divide by 25 here, divide by 25 here, and you end up with x equals 11, and we're talking about how many miles? X equals 11 miles. And does that check out with our chart? Does 11 fall between 10 and 12? It sure does. Okay, so this is the basis of this whole lesson. Now I'm going to walk you through a more detailed problem of the type of things you might see on a homework assignment or on a test. So let's turn to page 36. So page 36 starts with exercise 1, and as you can see, you have different parts to this, and that's more like how you're going to see a question set up in the homework or on a test. So question 1 says, Wesley walks at a constant speed from his house to school 1.5 miles away. It took him 25 minutes to get to school. What fraction represents his constant speed, c? Okay, so we're just breaking this down now. So his constant speed, c, is equal to, and we're looking for a fraction, and we're going to put the information in that we have. So 1.5 miles, and it takes him 25 minutes. And this is our constant speed then, c. This is also known as a rate of change. And I'm throwing this in right now so that later when we talk about this, we can refer back to it. So that's the first step. And then it's broken down. So part B says you want to know how many miles he has walked after 15 minutes. Let y represent the distance he traveled after 15 minutes of walking at the given constant speed. Write a fraction that represents the constant speed c in terms of y. This is scary because there's so many variables and so many words. What this is asking you is, okay, and I'm going to rewrite this just to show you. We've got this. We've got 1.5 miles in 25 minutes. Now it says, how many miles has he walked after 15 minutes? So we're going to set up a new fraction. And where should 15 minutes go in our new fraction? If you look, before we put minutes at the bottom of our first fraction, so we're going to put minutes at the bottom of this one. 15 minutes goes here. And then the top of the fraction, it tells you let y represent the distance he traveled. So we're going to make this y miles. Okay? So this is written in terms of y. So this is our answer for part B. Now part C asks us to put this all together. It says write the fractions from parts A and B, so right here and right here, as a proportion. Remember, a proportion means we have two rates that are equal to each other. And solve it, okay? So our proportion is going to start always with our rate of change. So on the left side, we're going to have 1.5 miles over 25 minutes. And then we're going to put in our new values. We were given 15 minutes, so we're going to put this at the bottom to match up with minutes here. And y miles. And then to solve it, we're going to set up a linear equation by cross multiplication. So 25 minutes times y miles is going to be equal to now 15 minutes times 1.5 miles, okay? So if you put that in your calculator, and on this side we don't have anything to calculate, but on the right side we do. If you put that in, 15 times 1.5 is 22.5. So now you have 25y equals 22.5, and now we're going to divide by 25 on both sides, and you end up with y equals 0.9. And remember, we want to put a unit on that. Y was y miles, so 0.9 miles. So what that's telling you is if he can walk 1.5 miles in 25 minutes, that means he can walk 0.9 miles in 15 minutes. Okay, and then the last part that we're going to be asked to do today is to write an equation, write a linear equation. So I'm going to move this up a second so that we can see the question. So part D says, let y be the distance in miles that Wesley traveled after X minutes. Write a linear equation in two variables, okay? A linear equation in two variables means we want to have an X and a Y, and we want to set it up like this. We want y equals whatever our rate of change is, I'm going to call that ROC, times X right now. Y equals our rate of change times X. So write a linear equation in two variables that represents how many miles Wesley walked after X minutes, okay? So here's how we're going to do this. It's really not rocket science. We're going to set it up like this. Y equals, and we're going to look back at our work. Our rate of change was our initial values, C right here. So here's our rate of change, 1.5 over 25. So y equals 1.5 over 25. And I like to put that in some parentheses, and because a lot of times it's going to be a fraction, times X. And that's our equation that we're going to use.